Hello, everybody. How's your Thursday? Hey, Sotek, Josh, welcome. Hope you're all doing well. Turn on rotational labels. Hey, Max, how you doing? Morning, huh? Where in the world is it morning? Maybe an Aussie? Hey, David. Hey, Derek. Cancer Night, welcome. All right, well, we can, sound is low. Oh, it is. Let me fix that. All right, that should be fixed. I don't know what keeps lowering my mic volume. I wish I did. Hey, Rocky, welcome. Warm for me? It is in the house. Ooh, a snowy storm for you? Yeah, it doesn't snow here, so. School canceled already tomorrow. Nice 3-day weekend. All right, well, let's get started. So this puzzle's called Oh Rats. It's by Ratfinkz, aka Sarah. So we have normal Sudoku rules, standard thermometers, so digits increase from the bulb end, and circles other than this bet cell. These circles mark odd digits. All right. Let's see here. How do we want to get started? Free digits box 5. Ah, yeah. So these are very free. This is a 5 and this is a 9. Those are the odd digits. These are 2, 4, 6, 8. This is a 5. This could be 5. This could be 5. So 5s are just up here somewhere. So let's see here. We could do 8, 7, 6, 5, 4. So this could be as high as 4 still. It's not a 3 though, so it's 1, 2, or 4. Oh no, we don't have 5. So 8, 7, 6, 4, 2. 2 is the highest it can go. Welcome, Sayori and SPQ. In this row, 1 is in one of these two. This row needs a 3. Is that interesting? It could go here, though. It could go here, here, here. It could even go here. It can't go over here, I guess is my point, but 3's in one of these. All right, let's see. So I'm tempted to just good lift these. Let's good lift this one. So this could be 2, 3, or 4. This can be 3, 4, not 3, so 4 or 6 only, I think. And then we've got 6, 7, and 7, 8. I could good lift the long ones as well. They're not that long though. Let's see. Two, 3, 4, 5. I'm just gonna finish good lifting them and then clean them up. So these aren't 5 or 7, so these can't be 6. And then these aren't 3, so these can't be 4. There's a 3 up here. We have a 6, 8 pair, so the rest of this row is 1, 2, 3, 4. This one's not a 3. Oh, whoops, yeah. So 9 in this row is in one of these two. Yeah, so if I made this as big as possible, I could go 9, 8, 7, 6. So this must be at most 5, but it can't be 5. So these are from 1, 2, 3, 4. Hey, Hunting Spirits, welcome. Ice Cube points out that we do have an X-wing on 9s in these cells for the rows. So that eliminates 9 from the columns. I'm not sure if that's useful at this point, but it's true. Let's see. So let's think about this one. 9, 8, 7, 6. I mean, this could be as high as 5. Okay, I'll good lift this then. So 2. We have all of the odds except 9. So this is 2, 4, 6, 8, and 9. This can't be 8 or 9. That can't be 9 either. Can't be 2. So we have a 4, 6 pair here. So these are not 4, 6. So 9's in one of these two. Welcome, Panthera. So basically we need to place 1, 2, 4, 5, 6. Okay, this cell here is 2 through 5. 2 through 4, actually. So that we need 7, 8, 9 in these cells. So this one's not 5. Not a 9 either. So this cell's 1, 2, or 3. That gives us a 1, 2, 3, 4 here. Oh, right. 6 in the row only goes here now. That's a 6. That's a 4. So this is 8 or 9. We have a 7, 8 pair here. True. So this is 6. These are not 6. Seven in column 4, says Josh. True. We need a 7 in this column. Can only go in one of these two. So this is 8 and this is 9, and that resolves our 9 X-Wing. And a bunch of other stuff, apparently. These aren't 2s. This is a 7. Get rid of our green here. These are not 8, so these are not 2 or 4. That's an 8. That's not 9, so that's a 6. 5. 4. 8 and 9. Wow, that was a very good observation about 7s. Missed a green. Yeah, we have an X-Wing on 1s here for the rows. So that makes this a 3, 4. This is a 1, 2 pair, so this is 3 and this is 5, 6, 7. We do have 1, 2, 4. How about this column? There's 3 digits left, so I need... Oh, this 2, 4 pair is probably going to help this cell here. But anyway, I need 1, I have 2, I need 3, I have 4, and I need 5, which can only go up here. Antonite says this is an 8, but I don't see why. Oh, it's hidden in the row. So we have this 6, 8 pair looking at this cell, and we have this 8 looking at this cell. So 8 in the row can only go here. That's a very good spot. These are from 1, 5, 7, it looks like, and 5 can't go in either of these. So 5 goes here. 1, 3, or 7. Hey, evening DJV. Zombie Hunter says 9 and box 6. Yep, it's placeable. So, thinking about 1, 2, 3, 4 in this column, we have 3 of them already. Only one more can hide over here. I guess one can hide here. We have the 3 already hiding here. Never mind. I don't think that's helpful. I was trying to roll out 4 from here. Well, there's no 6 here. Is that helpful? No 6, 8, or 6 or 8 here. So what are the biggest these could be? We have 9, 8 already. These can have 7, 5, and 4. That's the biggest these can be, 7, 5, and 4. So this can't be a 4. This isn't a 1, 2. Do we have the same thing here? We don't quite have the same thing here. In fact, is that what these have to be in order to avoid breaking this? No, we could put a 2 in here. Let's see. SPQ says last 9 in box 7. Yep, that's a 9. Zombie says 8 in row 8. Can't go here. So I think it must go here. Okay, what was Antonite's point? 7, 8 pair in column 3. So you have 7, 8 looking at row 7, column 3. And have 7, 8 in box 4. Right, so 7 and 8 are hidden in the column, and now with this 8, we can actually place 7 and 8 like that. Very nice. So these are, we have 1, 2, 3, 4, we need 5 and 6, that's it, and these are placed. That's 8 and 6. SPQ says 7 in row 8. Ah, yeah, that can't be a 7 now, so that's 7. I was like, I swear I just looked at that and didn't see the 7. Now we need, well, we have 6 and 5. Now we need a 4. So, can this be a 4? This would have to be 6, exactly. So this could be a 2, a 3, a 4, or a 6. Oh, it can't be 6. There's a 6 in the row. It can't be 6, 7, 8, or 9, or 5. So this can't be 4. That's a 1, 2 pair. This is a 4. We have 1, 2 pair here as well. So this is 3 and 4. Very nice. All right, this is resolving. Betsol was a 3. Congrats to Bremster. All right. Let's see. I am going to hit mark at this point. Okay, we found a naked single. Thank you, Mark. And this should just finish now. As I suspected. Very nice. Thank you, Sarah. Hope you enjoyed my solve. Very nice puzzle. Alrighty. Very nice. Good start to the stream. I enjoyed the interactions between the thermos. The odd cells were a bit odd because they could have just been given. they were basically given, but you know, I think it was probably done for aesthetic purposes. Very cool. Let's see. I need to double check. I don't think I have any. Do I have any super supporters who submitted? Oh, I do. I'll make sure to do that one this stream. Yeah, you did, Sotek. We'll get to it this stream for sure. All right. There are two. There are two. Okay. I think we can do them both this stream and still do this one first. I want to do this one while Sayori is able to watch, because Sayori generally is on library internet, which is timed. All right. This puzzle is called Regional Sandwiches by Sayori. So we have normal Sudoku rules. Clues outside the grid indicate the sum of the digits between 1 and 9 in that row or column. So standard sandwiches. So if I have the 1 and the 9 here, then these two sum to 9. And if I put the 1 down here, then these two would sum to 10, or these three could sum to 10, etc. Blue lines are region sum lines, where segments of a line passing through boxes add to the same number. So these two, let's separate this line into 3 colors for the 3 regions it passes through. A box is also called a region. So purple adds to the same thing as green, which adds to the same thing as blue. And that's it. Those are the rules. And let's get started. So how do we want to get started? The link. We want to get started by providing a link and a bet cell. There's the bet. The first puzzle you made after 2 months of no internet? Wow. 2 months without internet is a frightening thought. So this is like an arrow. So these 3 sum to this. So this is at least 6. Let's think about this then. So these together are 6 cells. They add to at least 21. This can be at most 9. So these two add to at least 12, which isn't all that exciting. Oh, regional sandwiches from Zombie Hunter. A grinder, a slider, a Reuben. On the East Coast, they call... they have hoagies, which are a form of, like, sub. So the term hoagie is regional. Let's see. Philly cheesesteak, true. Do I want to think about the max these can add to? I don't think it's very low, because it's 17 plus 9, so that's 26. So these add between 21 and 26. These can't exceed 6. Well, in general, these can't exceed 9. You put one given in a puzzle once, it was for a Secret Santa. I wanted to throw him off the scent. Nice. Oh, is a hot dog a sandwich? Let's not start that argument, Josh. These 5 sum to these 3. Is that interesting? I still haven't broken into this puzzle, by the way. All I have is this 6, 7, 8, 9 written out. We've got all of these. Again, that's 21 minimum. Column 7, maybe. These add to at least 15, so these add to at least 15, but that's not that interesting. Are the sandwiches useful? I haven't seen a use for the sandwiches yet, other than maybe we can roll out 9 from here. But I'm not sure how I would roll out 9 from here. I mean, neither of these can be 9, I guess. So we can't do 9. Well, I guess 9 has to be in 2 anyway. I was going to say we can't do 9, 9, 1, as if that were a great insight of some kind. Let's see. Yeah, column 7 does have a sandwich. Neither of these can be 9. But we could put a 1. It's kind of the issue. So that's not 9. I think I could do like 9, 1, 2 and be fine. Well, that breaks this one. But I could do a 9, 1, 3, right? No, if I have a 1 on here, then this has to be 2, 3, 4. So if maybe 9, 2, 3 would be fine. No, 9, 2... 9, 1, 4 I think is the smallest I can... No, 9, 1, 5 is the smallest I can make it. Nine, 2, 4 is the same. So 15 is the smallest this can be, right? If I use a 9. But that still works. All right, Sotek has some kind of point. If row 3, column 9 is a 9, where is the 1 to fulfill the sandwich? Oh, that was SPQ's point. Super broken, actually, because you cannot possibly do 9 and 2 then. So this can't be a 1. If I put the 1 here, this would have to be 9. So the 1 would have to be here, exactly. And then these would have to add to 9. But 9 is not an even number, and 2 of the same digit, this sums to the same as this. So if you sum them together, that is going to be even, which is certainly not 9. And if I make the 1 farther away from this 9, then now I just can't reach 9 at all. So yes, this is not 9, and there's a 1 on here. We have something. So neither of these are 9. This could be a 9. So now these can't add to more than 25. Maximum length of a 10 sandwich? 2, 3, 5 is 10. But this has to be pretty big, doesn't it? At best, this is... Hold on, how... If we want this to be small, we need this to be big. But we know these add to at least 21. So we could just say 21 minus 8 is 13. So this adds to at least 13. We don't have to have a 1 or a 9 in column 7 in box 6. We do need to. We need 2 cells in the sandwich to make 10. So how would we avoid these not being in the sandwich? We'd have to do that or that, and that doesn't work. So there is a 1 or a 9. Oh, there is a 9 on this. There is a 9 on this line. That's interesting. Okay. So 2, 3, 5 would break our 8 sum. Row 7, column 5, 6. Yeah. So, oh yeah, interesting. So if we did, so 15 plus 9 is 24. So these are, and this is at most 8. I don't think this can even be 6 anymore. Because if this was 6, I'd have to hit 24. I just have to add to 18. So this is 7 or 8. And these are 7, 8, 9 with a 9 on them. So they're either 7, 9 or 8, 9. And so 7 and 8 are outside of these sum lines. We're either 1, 2, 3, 4, 5, 9, or 1, 2, 3, 4, 6, 9. Okay. Yeah, forcing a 9 onto here was very interesting. The 1 is outside of it, but... Okay, if this was a 9, it doesn't go down. Because if this was a 9 and this was a 1, these two would add to 10. That would make the line 19, which isn't possible. Now, could I do 9, 1 with... And I can't do 2, 3, 5 here, can I? No. Maybe I could, actually. Actually, I don't know if I want to roll that out. Yeah, I think it's just possible. So if 9 here could go down, but it would be a 3-cell sum. Same with 9 going up. Same deal. So there's somewhere else to look, I'm sure. These don't have a 9 on them. I'm sure that's very interesting. Are we worried about the 1 being on here? Not really. Row 7, column 4. True, this is another single sum. So this can't be 9. Yeah, we could add to 5 in 2 different ways. So this is at least 5, and it can't be 9. Derek says row 3, column 9, in column 7. So this cell can't repeat in the box and doesn't go on this line. So it's down here somewhere. Is the question whether it can go on this line? Well, this can't exceed 8. So we could just do 7, 1. Is there a reason 7, 1 is bad? Seven, 1, 8. Seven plus 7 plus 9. Oh, this can't be 8. Sorry, if this was 1, 7, this would be 8. And now we would have 7 here. I guess I should go back one further. If this was 7, and the 7 were placed down here, on here, that would be the only way green ends up down here. This would be an 8. And then these would sum to 23, which isn't big enough. Because these sum to 24 or 25. So there is no way for green to be on this sum. And so this is a 7 or 8. So now the 7 8s here are different 7 8s, so they sum to 15. So this sums to 24, so it has to be 1, 2, 3, 4, 5, 9. Basically 6, 7, 8 are here. Let's just do that. These are 6, 7, 8. These are 1 through 5, I guess. These are 1 through 5, and by marking that, Derek's point is we have a quint here. So these are from 6, 7, 8, 9. We can't put a 9 on this line because it sums to a single digit here. This can't be 6, 7, or 8, so this is the 9. I don't know what happened there, but it didn't delete it. Very nice. Okay. So this could be a 9, and if it was, this can't exceed 3. This could be as low as 3. I think I missed something from Ice Cube. Row 7, column 4. If it's 5, we have 5 digits in row 5. That must be from 1, 2, 3, 4, 5. I think that's true anyway. We covered it? Okay. Derek says if it's 5, then 5 in row 5 is in box 6. Okay, if this is a 5, then this is a 1, 2, 3, 4. So the 5. So if this is a 5, none of these can be 5. So the 5's over here, making that an 8. Right? Yeah, because 7 is 1, 2, 4. Oh, and if this is a 6, then we can't put 3 on here. That's going to put a 3 over here. And again, 3 isn't involved in the 7 sum. 7 sum is only 1, 2, 4. So no matter what, green is 8. Wow, okay. That is very cool. Oh my gosh, my hand. 2, 5, or 3, 4. Okay. This adds to at least 7. It's not an 8. Interesting. So that's a 7-9 pair. This is not a 7. Get rid of that. Oh, this is even? That's odd? True. So this has to be odd. Can't be a 2. That's always a fun trick. How does the oh, we do have this 9 placed now, and now we know this is a 10 sandwich glue. So this could be a 1, and this could be a 2. That's one option. If we went up, seems not too difficult to reach 10. Would 1 here work? Could we do 2, 3, 5? Seems doable. So I feel like 1 can go here, here, or here. Yeah, I don't see what to do with that. Unless 1 can't go over here. Make these 2 consecutive. This being the larger one. This can be as big as 6. So we could do like 6, 1, 5. Also, welcome Math Pesto. If row 4, column 6 is a 1, you can't put a 1 on the 5, 6 line. True. Because if this is a 1, these are 1s, and now this can't have a 1 on it. But we know there's a 1 somewhere on here. Nice spot. Because it's either 2 ways to add to 5 or 2 ways to add to 6, both of which involve a 1. So this has to be a 3. So we have to do 3, 6, 9. That should be helpful. That's not a 3, so that's not a 4. Because these 2 add to 7. There's no 3 on this line, so this can't be... Oh, this could be 5 if it was 1, 4. Never mind. This 9 means that there's a 1 here or here for our sandwich. Very nice spot. I'm assuming that's true of both of these as well. So one's down here somewhere. Ice Cube says if row 1, column 7 is 1, we have a 6-7 pair at the bottom of column 7 adding to 13. Oh, true. Yeah, if this was a 1 with a 2, 3, 5 here, then 6 and 7 have to go somewhere. They would go down here, and that would add to too much for this guy. What can this be? It can't be 3. So I guess it's 4, 5, or 8. Something to keep in mind. So 1 is either here or it's here. If the row 3 sandwich is 2, 3, 4, what are we putting in box 3, row 3? Right, so in general, this needs to add to 9. It's going to have a 2, 3, or 4 in it. Yeah. Because we can't use 1. Because 1's over here. So this will have a 2, 3, or 4 in it to add to 9. So this can't be 2, 3, 4. So this is the 1. Okay. So these add to 10. No, these add to 9, sorry. These add to 9, and these add to 9. So I suppose these add to 9? Hold on. Maybe not. Hold on, wait. Yeah, we got 9, 18, 27. What did I want? 9, 18, 27, 36, 45. So these add to 9, so these add to 9. I think putting a 1 here has the same issue, doesn't it? Or maybe not. 1, 8, 2, 7, or 4, 5. So these are the 3 ways to add to 9. We place this 1, that has in a greater than 11, so the 9 doesn't go up here. The 9 doesn't go here. We can't actually, oh, we could do greater than 11 from here. Nine in box 5. 2 places? Is there, oh wait, no, this 9 looks down. You're right, it's in 1 place. Okay. Why can't 9 go lower? Oh, never mind. Okay. This greater than 0 makes me think the 1 goes here, because if it were here, then it's obviously greater than 0, but I don't think I can use that logic. Interestingly, if this was a 6, then we could only put the 6 here. But I don't think that does anything useful. Could be the greater than 0 is forcing the 1 over here? Maybe. Yeah, we can't really make any assumptions about that. I'm not going to. So these are consecutive. And this is smaller. So this can't be 8. We could do 2, 3, 3, 4, 4, 5, anything up to 8. Up to 7, 8. I don't know what to do with the secret in row 3 zombie other than what we already said, which is these add to 9, these add to 9, and these add to 9. Therefore, these add to 9. Is there something more about the secret that you'd like to tell us? Because we already sort of noted that. Antonite thinks that row 4, column 7 is a 5. Can't be 2 or 4. Why would it need to go upwards, though? Well, okay, so 2 we might be able to rule out. Let's look at 2 first. If this was a 2, then the 9 can't go downwards, so the 9 goes upwards. And so we'd have to go all the way up to here, and we said that that doesn't work. The 1 would have to be here. We can't do 2, 8. Okay, so that's true. This can't be 2, so that's not a 5. If this was a 4, then this would be a 3, and we still can't go downwards. Oh, interesting. So this would be 6 and 3, but I don't see an issue with that. Okay, but at least it can't be 2. It does break. Does it have to do with having to sum to 4, 5, or 8 here? 4 would be 1, 3. So if this is a 3, we can't add to 4. Oh, okay, so if this is 3, 4, we have to add to 8, don't we? Because we don't have a 3 or a 4 to add to 4 or 5. So how are we adding to 8? We could do 1, 7. This would be 6, right? And this would be 1. Oh, so we could do 1, 7, because the 1 is used in the sandwich. Can't do 2, 6, can't do 3, 5. Okay, yeah, it breaks this sum. So it's not 3, 4, it's 2 and 5. Okay. So we could smack a 1 here. If we put a 1 here, then this would be... Oh, well, we can't... Okay, the 1 does go here then. Because we can't make this a 5. So this is a 1. Now we have our 10 sum done. So this is 3, 4, or 7. Okay. Progress. Right, so 5 is in one of these 3, which means we can't sum to 5. For the row, 5 is in one of these 3. So this is a 6. So there is no 3 over here. There is a 3 here. Okay. So if that's not a 1, that's not a 5. This isn't a 2, so that's not a 4. This isn't 1 or 2. It's not that helpful. Okay. Melkor says let's look at this line here that adds to 9. Could be 1, 7. Could be 1, 7 doesn't add to 9. We're adding to 9. Well, it could be 1, 8. Could be 2, 7. Can't be 3, 6. Can't be 4, 5. So we do have a 7, 8 pair here. We also have a 1, 2 pair here. Sotek is an interesting point. Five's in one of these two. No matter what, this can't be a 5. Because if this is a 5, then this has to be 2, 4. So this one's not a 5, so that one's not a 1. But we have kind of 1, 2, 7, 8 accounted for in here. I'm wondering if that's interesting. Not to me. I guess we could point out that this cell here, which I'll mark green, in this row can't go in any of these cells. Because these are 4 distinct digits. So it's the 1, 4 that goes over here. That isn't a 3. So it goes up here. So if it was a 4, this would be 4. I don't know if that's broken. If it's a 1, then this is 1, 8. If it's a 4, then this is 4. This is 1, 5. This is 2, 7. I don't know. They're different cases. 9 in column 3, I'm being told by Zombie Hunter. I don't know where to put the 9 in column 3. Row 4, column 3 candidates. Okay, it's not 1. It's not 2. We have a 1, 2 pair here. So it's not 1, 2. It's not 3. It could be 4. It's not 5. It could be 6. It's not 7, 8, or 9. How you make the greater than 11 work? It can't be here anymore, because this is limited now. That's true. So 9's on this sum. Got a 9 over here. A 1 in box 8. We can't put a 1 in this sum anymore because there's a 9 over here. This adds to at least 11, so this can't have a 1 on it. So 1 is placed. Okay. 1's not here. 1 in box 7 is on this line, true. So this can't be 9, because this would have to be 1, 8. So it places this 9. So 9 up here. This line, we're trying to maximize it in chat. So it could be 8, 5, which is 13. So this is max 13. So this is 9 with a 2, 3, or 4. If it didn't have an 8, we'd be 5 plus 4, which is 9. So we do have an 8. So that's not 8, so that's not 7. So there's a 6 and a 7 up here. Right, this can't be 7 or 8. This can't be 7 or 8 because we have the 7-8 pair here. So 7 and 8 go here. Nice spot, Zombie Hunter. Oh, huh. So the question from Admar Melkor is, where is blue in this box? It can't go on its own line because otherwise it would have to be 8 or... yeah, it just doesn't work. These are two different ways to sum to the same value. And it's not 1, so it has to be 6, 7, or 9. So it must be a 9. The only option. Very nice. 9's down here. So this adds to 11, 12, or 13. 8, so that's 8 plus 3, 4, or 5. If this was 8 plus 3 or 4, then we'd have a 3, 4, 8 triple. And that would force this to be a 2, so we'd add to 11, so it would be 8, 3. So 4 isn't possible on here. So we can't be 8, 4, which means we can't be 9, 3. What can this actually be? It can't be 9, 8, or 7. So it's 3, 4, 5, 6, I guess? Three in this box is over here. I guess this is also 3, 4, 5, 6. Okay, so 6 in this column is limited to these two cells. So it's not here. I could put a 3 here. But only just barely. 3 is limited to these two. So this is a 1 with a 2, 3, or 4. That's worth marking, I think. I guess it just means not 5, because the rest of the column is 1 through 5. Well, 2 through 5. So what haven't we used? Sandwich clues, maybe? I feel like the only sandwich clue we haven't used is this greater than 0. Doesn't feel very useful at the moment. This isn't a 1-9 pair. That's basically what that's saying. The only place you could even risk having a 0 sandwich column. Alcor says there's a virtual 3-4-5 triple in box 8. Row 9, column 6. Wait. Row 9, column 6 is a 1. Row 9, column 7. Wait, row 9, column 7 is not in box 8. 3, 5, 8. Row 8, column 6. I don't know what to do with that. Sorry. Sotek wants to good lift row 3, column 7. And row 3, column 8. Sure. So we could be 3, 6. We could be 4, 5. Or it could be 7, 2. Anti-Knight has a nasty step. Green can't be 4. Okay? If it was 4, then row 4, column 4 is a 4. Row 4, column 3 is a 4, I'm assuming you meant. And row 9, column 3 is a 2. Okay? But it's broken now. You'll have to have 3, 6 pair. Three, 6 pair in row 6, column 1, 3. I followed you up to a point. There's an easy thing, fill in column 6. Okay. Column 6 is filled. Where's the 2 in row 3? Okay, so 2's in one of these two. Can this not be 2, 7? This, oh, okay. That's a good spot. These 2's claim these two. This can't be 2, 7 because of the 7, 8 pair up here. So this has to be 2, 7. Okay. That's not a 2. These are 3, 4, 6. Okay, I'm going to look at this again. If this is 4, this is 4, this is 2. I agree with that. This is 1, 5. Ah, and now this is 3, but we can't put a 2 on here. Yikes. Do I want to use that? Is there a nicer way to see that? This is 4, then this is 4, 6, and 3. Okay, so Derek's point is a little bit easier to see because of our corner marks. If this was a 6, then this is a 3, But now we have 4 and 2 here, and this 3 requires a 2 here. So this can't be a 6. If that's not a 6, then this is a 6, which means it's not green. Which means green can't be 4. Green is 1, so that's 5. Now I have a 2-4 pair here. This can't be 5. Two 4 pair places the 4 here. We know there's a 1 here, so this isn't 2 7. And now I can get rid of green. So this is 1 2 or 1 4. It's not 1 3. The 1 8 pair sees here. That's 7 6 and 8. That's a 4. This is a 2. This is 5 and 4. So that's a 2. It's all working. I think that cracked it. That was quite the step, though. Got 4 and 2 here. These aren't 2. Okay, let's take a look at what we got. This is 7 or 8, not an 8. Three and 8. Let's fill these. We know these add to 7. 4 5 or sorry, these add to 9. So it's 4 5 or 3 6. Same thing here. But that's just the row. Well, this can't be a 1, because it would have to be 1 8, because 1 2 is way too small. And 1 8 adds to 9, but with a 3 6 here, this would have to be another 3 6 to add to 9. So that's not a 1. So the 1 goes here. Wow, there's a whisper in box 1 too. I'm just kidding you. This can't be a 2, so that's not a 3. This could be 3 or 6. That's a pair. If this is 3 or 6, then this is not 3 6. That's 4 5. So this is 3 6. This is a 5. So these add to either 7 or 5 plus 8 is 13. 7 or 13. So to get to 7, we could do 3 4 or 6 1. To get to 13, I need 6 plus 7, and I can't. So this is a 2. That's a 4, that's a 7. Let's good lift these. No. It's good lift. Yeah, sure, why not? Row 2's got a triple left, that's true. 5 9 pair sees here. This is a 2. That's a 9. Bet cell was a 9. Congrats to 9 betters. This is 3 or 6. So this is 1 or 4. It's not a 4, so that's a 1. And now we're greater than 0 comes into play. These add to 7, so we need 4 plus 3. So this greater than 0 did these 2 rows, seems like. 2 7 9. That's not a 9. It's not a 6. We have an 8 here. Looks like the rest of this just resolves. Maybe? Oh, these add to 5. Very nice puzzle, Sayori. Thank you. A little fiddly with the interaction here with this 2 and this line. Interesting deduction there. But yeah, I enjoyed the logic of box 6 especially. That was really interesting. How 9 got forced on it because of the sandwich. That was very cool. And then this just kept preventing certain options in all sorts of ways. Very interesting. You don't remember if it was intended, but you wouldn't be surprised if it was? Okay, well, I don't feel too bad then. All right, I've got 2 super supporters to take care of here. Okay, super supporter number 1. We have a bet cell in row 7. Ooh, I can turn on row column markers. Row 7, column 9. All right. Here's our bet cell. Oh, wow. Hey, Endless Vids, how you doing? All right, this is called Kyoketsu-shoge by Sotek. So we've got standard Sudoku rules, standard German whispers, and then rotational pairs. So German whispers, digits that are next to each other on the line, have to have a difference of at least 5. Rotational pairs. Every digit except the digit in the center, row 5, column 5, has a partner digit that is always placed 180 degrees rotationally symmetric to it, seen from the center of the grid. Which digits are paired up must be deduced by the solver. For example, if the digits 1 and 2 turned out to be a rotational pair, and row 2, column 4 was a 1, then row 8, column 6 must be a 2. So if we rotate the 1 100 degrees around the middle, then we get to this cell. And this cell needs to be its partner. Now we have to deduce the partners. So I'm most interested in what the partners of these givens are. So let's see here. The partner of this given is here. The partner of this given is here. And the partner of this given is here. So we'll keep that in mind. That should maybe tell us some partners. So 7 does not partner with 3. Yes, don't forget to like the stream, everybody. 5 and row 6. True, 5 and row 6 is just placed. So where's its partner? Over here, I guess? So 5 matches up with not 5. Can a digit match up with itself? I don't think there's any rule that it can't. That is not the partner. Oh, the partner's here, sorry. Still on a whisper. Now 5 in row 4 is over here. So that's the same partnership, so I'll keep using gray for that. That goes here. Okay. Right, whatever goes in the center partners, well, it says except for row 5, column 5, but if we think about it, the only digit that can go in the center is the one that partners with itself. So this is some other color. This is, let's not use orange, let's use red. Red is a digit that partners with itself. Of course, there must be a digit that partners with itself, otherwise, because there's an odd number of digits. So there's going to be one that doesn't pair up. And that goes in the middle. It's not 3, 4, or it's not 3, 4, 5, or 7. So it's 1, 2, 6, 8, or 9 for what it's worth. True. Because of box 5, everything else is going to pair up with something. Right, so this isn't 5, so this is 5. That's true. And it pairs up with this digit. Are we roped? Because these two do pair up. We could be roped. Easily. SPQ says not roped. Yeah, so 5 doesn't pair up with 3 or 7. They pair, so they're not equal. If they were red, they'd be equal. Gray needs to be able to partner with 2 different digits, so it's not 4 or 6. So 5 partners with 1, 2, 3, 7, 8, 9, but it doesn't partner with 7 or 3, apparently. We have another partnership here, right? There's 4 partnerships. These partner, so let's pick a color for that. I'm avoiding blue and orange, or I guess I should have avoided blue. I didn't. So we don't know what this 4 is. Blue is something. What do I do? I don't know what color this is. So let's leave that alone for now. Okay, what do we want to do? Yes, this is a partnership. Do I know what color it is? Do these have to be red? I don't know. I feel like these could be yellow, for example, and we'd be fine. They could be green. They could be purple. I don't think they have to be red. Well, we don't know 4 and 6 pair up. Do we know that it's a 4 and 6 pair? I think it's not. I think it's not a thing. Let's see. Row 5, column 2, and row 4, column 3 are opposite polarity. I don't understand that. Trivial 5 in column 7. True. We get a 5 down here. That's gray. So then that rotates to here. If I'm doing that right. This is a 1, 2, 8, 9. Hey, Robert, welcome. Sudoku Marathon today? Yes, these two are the same. These are the same digit. So these two are the same polarity. I haven't done any polarity coloring yet. So I could start using orange and blue and just hope that I guess right. Me, Marister, Bremster, and now me. Nice. Can't get enough Sudoku. So we know all these are orange. These are blue. This is blue and orange. Box 8 has 2 places for 5. 2 places for 5. Bremster's been streaming gas puzzles, and then also he did a Sudoku Adventure stream the other day. 5 doesn't partner with 4. How do... Oh, do we know that? Do we know that 5 doesn't partner with 4? All right, 5 partners with 1, 2, 8, or 9. So 5 is in one of those two. If we're roped, these are red, and there are 1 or 2. Oh, we don't know blue is low. I'm confusing myself. 4 in box 5 feels interesting. Not so interesting to me. I feel like it could go anywhere. Oh, box 5. It's not here. It's in a corner? So what we're saying is 4 does not pair with 9. Is that what we're saying? Because all the pairings need to be represented in this box. Okay, so 9 is either here, 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 or here, and they all see gray. None of these are gray. We have all our grays accounted for in this band. So 9 is not... Gray is not 9. Okay. Red is not 9 either. And 4 does not pair with 9. Is it the same for 3? 3 is a little bit harder. I suppose because we have in these rows, we have individual whispers. We're going to have 4, 9, 3, 8, 2, 7, 1, 6. Why is red not 9? Actually, red could be 9, you're right. So we're going to have an 8. We're going to have an 8 in one of these cells. None of them are gray. Wait, what if red was 8? Would red be 8? I'm getting confused. Well, we're going to have a 3. We're going to have a 3 somewhere here. If the 3 is somewhere here, then there's an 8 somewhere here. So 8, gray is not 8. Okay. So gray is actually low. So let me okay, we're going to make orange black for a second. Then we're going to make blue orange, and then we're going to make black blue. Okay. So we have our low high now. This is 1, 2, or 3. So 3 is low. 7 is high. 4 is low. We've proven 4 is not gray. So 1, 2 is going to go with... Oh, no, we don't know. Okay, these oranges are going to be from 6, 7, 8, 9, but these aren't 7s. So are these. Tom, what do you mean? Oh, this can't be right. We know that this is we just said we're going to have 1, 6, 2, 7, 3, 5, and 4, 9. Sorry, 3, 8, and 4, 9. So if this was 2, this has to be 7, but it can't be. So actually, these are gray is 1. So 5 pairs up with 1. And this is a 6. So and the 1 goes with 6 here as well. So this is roped and 6 is red. Nice. So now because we're roped, let's see, maybe not because we're roped. Hold on. This, what can this be? This can't be 1, 6 or 2, 7. So this is 3, 8, or 4, 9. That's not a 1, by the way. Do we want to continue coloring low high? I suppose we should. I don't know how useful it is. So we have a virtual 8, 9 pair here. So this can't be the 4. So where's the 2, 8? No, where's the 2, 7 in this row? The 7 is up here. Okay, so 7 and 8, 9 go together, and we know the 7's up here for the row. So this has to be the high. No, it doesn't. They can be next to each other. Oh, darn! It's not a connected line. Right. This is, hold on. This is not 6. Are you sure? Okay, if this was 6, then okay, this one mirrors where? This one mirrors here. Okay, so if it was 6, then this is also 6, and this would have to be 1, and it can't be. Okay, so yes, that is not a 6. Oh, also it would be next to a 2, 3. That is a lot easier. Right, we have a low and a high here, so this has to be high. That's true. This is a 7, 8, or 9 because of our roping. Then we have a green, purple, yellow. So we know there's a, oh, the low is the 3. No, the low is not the 3. Never mind. Okay, I have to put a 6 in this column somewhere. Not here, not here. It's not on this line because we have a 1 already. It's not on this line because we have 1 already. And it's not in this box. So this is the 6. And that's red. So now we can mirror that here. Get a red 6 here. How are we doing on 6s? We got a 6 up here, and I'm betting if we look at the rotation, well, the rotations are here. I can't rule out 6, 1 yet. 1 maps to 5, though. So if this was, okay, if this was 6, this would be 1, and this would be 5. That seems okay. Unfortunate. Okay. What else would we do? If this was 4, we'd be 4, 9, and green would be 4. It'd be 4, 9, 7, 2, and this would be 4. Green would be 4. So this would be a 3, but more importantly, this would be a 3. And this would be an 8. It all works. And that would mean 8 and 9 pair up. All right, Zombie Hunter says 1 in box 2. Interesting. So in box 2, 1 is in one of these 3. Let's rotate that. So that rotates here, if I'm doing that right. No, that rotates here. Okay, well, if 5's in one of these 2, that rotates here. That means 1's in one of these 2. Okay. And now 1's in one of these 2, which means 5 is in one of these 2, I guess. Kind of Sudoku tells us that anyway. Hmm. 6 in this box is in one of these 3, which is going to map to these. But this can't be a 6 because that can't be a 1. So if that's not a 6, then that's not a 6. That places this 6 in this 1. Which places this 6 and this 5. that places this 1 and this 5. Nice. This is high, 7, 8, 9, which maps here. That's true. This is low. This is 2 or 4. This is also low. This is 2, 3, or 4. This maps here. Zombie Hunter says, where is row 6, column 8, 9 in box 5 and box 4? So this rope in general is going to be here and here. So I need two, right, I need 2 highs here as well. So one of them's here. So this is low. So we have a low and a high mapping to each other. So these are not green. These are purple or yellow. And if it was purple, 7 can't map with 2. Because this would be 2. 7 would map with 4 only. Wait, no. 7 would... Wait. What am I saying? 7 could map with 2. No, I don't know what I'm saying. So these are the same as these. It's the same as... I'm not sure. This is lowest last low for the row. So Commander has 3 and Bucks 5, but it's somewhere. Somewhere is my answer. One of these. Not here. Oh, okay. So, right, this can't be 3. Because it would have to map to a 2-4 over here. So that's not 3, which means that's not 8. And tonight says row 6, column 8, 9 can't be 8 because you would need a 3 with it. Right. Okay. So now we have found the 3 in the row. This is 3, 8. Nice. Okay. So that's not an 8. That's not a 3. This is a 3, 8. So one of these is 2 or 4. 2 goes with 7, 4 goes with 9. That's not 4, so that's not 9. Three, 8 pair gives a 9 here. So this is not a 9. Eight in box 6. I mean, let me know if there's more than just that. These are in general 2, 4, 8. These are in general 2, 4, 7, 9. Oh, all our high digits are accounted for in the column. So this can't be high. So this is low, this is high, and okay, so 7 and 8 pair up. So that's purple. And that pairs up here, which is also purple, 7, 8. So it's orange, this is blue. This is 2 or 3. So 7 and 8 pair up. So what does that mean for this box? That means this can't be 7. It means this is 9, 4, and this is 2. So 2 and 3 pair up. This has to be 4 and 9. Okay. Now 7 and 8 can pair up here or here, and 2 and 3 can pair up also. So if 2 and 3 pair up, then that means this cell is also a 2, 3. These are green. these work out either way we want to do it. Here's not an 8. Care about this one? So 7 would pair up with 8, and 9 would pair up with 4. It's very different. These are from 2, 3, 7, 8. These go here, also from 2, 3, 7, 8. Nine's one of these. Okay, so 9s are yellow. So are 4s. So 4 goes here to a 9. So if this was a 9, then this would be a 4, and it can't be. Making sure I did that right. So this is the 9, which is yellow-orange. That's a 7, which is green. That goes to an 8, which is green-orange. These are not 8s, so these are not 7s. I feel like I missed something. 9 goes to 4 here. I'm being careful. This is 3 and 8. So 3 is blue-green, which goes to the 2 and 7, which is blue-green. 7 is orange-purple, so is 8. Okay. Yeah, I'm working on it. Did I miss any? Can't be 2, 8? Ah, because this is... If this was 2, 8, this would have to be 3, 7. It doesn't work. So this is 3, 8. Very nice. Which means this is 2, 7. Wait. This is 3... No. Oh yeah, this is 3, 7, which is fine. There's no line. I was very concerned for a second. So 2, 8 means that this is 7, this is 8, this is 2, and this is 3. Oh, I messed up. 3, 8. It has to be 3... Wait. It has to be 3, 8. Okay, if this was... Right, I think I said the logic and then I did it wrong. If this was 2, 8, this would be 3, 7, and that's bad. So it's not 2, 8, it's 3, 8. This is 2, 7. Okay. That resolves this as 7, 2, which resolves this as 8, 3. This is 3 and 8. This is 2 and 7. Okay, so these are green low. And these are orange, or these are high purples. This is a 2. 2 is also green. And this is something. This is 7. It's purple. Orange. So this is 8. We have 3 and 8. We have 2 and 7. These are purple, orange. These are green, blue. This is 3. We already had the rotation. We're going to do that. Okay, I think it'll just solve now. Very nice. Thank you, Sotek. That was a neat puzzle. Oopsie. And so I leave it as an exercise to the viewer to figure out if the rest of the rotations work. We can color them at least. So 3s and 2s are blue, green. 1s are blue, gray. 8s and 7s are purple, orange. 4s are yellow, blue. 5s are just gray. 9s are yellow, orange, and 6s are red, orange. Okay. There, beautiful. Not at all overcolored. Wait, what happened to this 7? Oh my gosh, 7, what are you doing? You're pretending to be someone you're not. Okay. Same with this one. I think I colored it wrong. 5 did not end up in the middle of a rotation puzzle. True. Here, we'll make 5s black to signify that they are not low or high. Does that make everyone feel better? All right, I have one more super supporter puzzle. Just a standard killer. All right. This is Danny Ocean by PjotrV. Thanks, Peter, for being a super supporter. And we just have standard killer. In fact, all the cages add to 11 and don't repeat. I'm not even sure if the non-repeat is needed here. All right. Well, the 11 and 4s, I know those. Those are 1, 2, 3, 5. So this is what, 4, 7? It's not 2, 9. It's not 3, 8. It's not 5, 6. Ocean's 11, yeah, it's cool. So these are 6, 8, 9. This is 4, 7. These are 6, 8, 9. We have a 4, 7 pair here, so this is not 4, 7. Antonite says row 7 has 1 hidden. Ah, true. This is a 1 now. 1 does not go in 11 cages, which should be useful. So 1 is in one of these two. Oh, no. 1 can go in a 3-cell 11 cage. So let's be careful about that. 1 does not go in 11 dominoes. Okay, so a 3-cell 11 cage has a 1 or a 2 in it, which won't go here. So this is a 1 or a 2. It doesn't have a 1 and a 2 in it because that breaks this cage. Row 6, column 1, in row 7. It's not here. Right, so green plus purple sum to 11. So purple's not allowed in these ones. So this is green. I don't think I need purple there, though. This would be 5 plus 6, or 3 plus 8, or 2 plus 9. Oh, okay. So if we look closer at our sum combos, or maybe if we did actual math, if this was a 2, okay, these sum to at least 21. These sum to exactly 21, sorry. So they have to be 1 through 6. If this was a 2, then these would sum to 12. Because this would be 1, 3, 5. So this is a 1. And these are 1, 4, and 6. Oh, wait, hold on. No, I did that wrong. Why did I say they added to... Right. These add to... Okay, the math is much simpler than what I just said. I don't know what I just said, but... I think what I said made sense, but I wasn't thinking about it right. These add to a minimum of 21, but these add to 22, so this has to be a 1. Now that this is 2, 3, 5, and these do add to 21, this has to be 1, 4, and 6. And it does work out. It was the same as what I said, but I wanted to say that cleaner. Hey, Nebu, how you doing? So these are 7, 8, 9. So this is 2, 3, 4. These aren't 1s, so there's a 1 down here. So there's a 1 over here. Whoa. Sayori says 9 in column 8. Right, 9 can't go in a 3-cell 11 cage. Can this be 9 too? Why is it placed? Oh, this 11 cage has a 2 in it. Right, so this can't be 9 too. So that's a 9. Good point. This is either 2, 3, 6 or 2, 4, 5. So we need a 2 up here. And now 9 in this row. 9's not here. 9's not in a 3-cell 11 cage. So this is a 9. These aren't 9s. This isn't a 2. 1 in 11 cage in box 7. Right, the 2's up here, so this needs a 1 in it. So now this has a 1 in it, and this has a 1 in it. So we need a 1 over here, which means this has a 2 in it. It's either 2, 3, 6 or 2, 4, 5. Nine in box 7. This 9 looks down. Ah, so this can't be a 2, because this would need to be a 9. 9's not in a 3-cell 11 cage. 9's not here. So there's 2 places for 9. Ah, but if this was 9, this would be 2, and this would also be 9. Because if this was 9, we couldn't put a 2 in this cage. So the 2 would go here, and this would have to be 9 as well. So this has to be 9 too. Green is not 9. Nice. 9 doesn't go in another 3-cell 11 cage, so it goes here. Well, sure, that's what you meant. Yeah, good spot, Ice Cube. 9's down here somewhere. Let's see. So this doesn't have a 2 in it. 137 or 146. I guess that means 8 needs to go somewhere. And 5? 5 and 8 need to go somewhere? Not enough. Is this limited? It's not 2-9, so it could be 3-8. It's not 4-7. It could be 5-6. It's like a 3-5 and a 6-8, yeah. Antonite is saying it can't be 5-6. Ah, we do need a 5 or a 6 in this cage. This can't be 5-6. Very nice spot. So these are 6 and 5. We don't need the green anymore. That's not 5, that's not 6. So 6s are here, looking down. So this doesn't have a 6 in it anymore. So this is 2, 4, 5. Eight in this column is in 2 spots. What do we have left in this box? Well, okay. There. Probably would have been easier to do it myself. We have a 1, 3, 7, 8 quad. So this is a 5. And so this is not 1, 2, 3. It could be 4. It's not 5. It could be 6. 4, 6 pair means this is 1, 3, 7. And this is the 8. That's a 7. That's an 8 with a 3. These aren't 8, so that's an 8. We don't need the 1s marked there anymore. This is not a 7. Chocolate teapot quadruple. These are not 3s. So this is a 1, 3 pair. That makes that a 7. Leaving a 1, 3 pair. That was a good amount of progress there. This is not 1, 4, 6. Oh, it's not any of the ones. It can't have a 1 in it. 2, 3, 6 or 2, 4, 5. Not 2, 3, 6. So this is 2, 4, 5 because of this 3. So we can place 1, 6, and 4 here, and the 4 here, and the 3 and the 1 here. Nice. And this is a triple. So we have 1, 2, we need 3, 7, and 8. So this is a 6, that's an 8. This is 4 and 7, 4 and 7, 9 and 8. Okay. This is a pair, 6 and 9. This is a triple as well. Let's just have Mark tell us. Nice. So this needs a 1 in it because it can't have a 2 in it. Oh, it could. No, this is a 1. This is the 1 or the 2 in here. But it can't have an 8 in it because it can't have both 1 and 2 in it. So this is the 8. Well, these add to 10, so this better be a 1. All right, 3 and 8. This is now 2, 3, 6 or 2, 4, 5. Either way, it's got a 2 in it. I feel like we're kind of wrapping up. Maybe there's a little bit left. We have all this here. What's this? This could be... It can't be 2, 9. This could be 3, 8, but only this way. Could be 4, 7, but only this way. And 5, 6, but only this way. Oh, no, it can't be 5, 6, because the 5, 6 is the call. I was looking at the rows. Not immediately helpful. This has a 2 in it. 3, 6, or 4, 5. So this has a virtual 3, 4 pair here. So 2, 3, and 4 are used up. Sayori sees 7 in column 8. Okay, so this certainly can't have a 7 in it. Right, and 7 plus 2 would require another 2. So that's the 7 in the column. So that's 4 and 7. I feel like this works out either way. These add to 9. So don't they have to be 4, 5 then? Only way to add to 9? So we have 1, 2, 3 used up. So this is 2, 3, 6. Okay. Okay, we got 6 and 4 used up. This is something. 7. These are lazy mark. Okay. This is an 8. This is a triple, which Mark will tell us. Okay. That's not a 1. So 5 with a 6 seems to work. Or 9 with a 2 also works. I'm just gonna mark the rest up. Oh, we have a naked 7 right here. Who knew? So this is 9 and 2. 5 and 2. 5 and 2. Let's clean this up. Okay. 1, 3 pair. Bet cell was a 5. And it looks like we're finishing now. Nice. Cool puzzle. All 11 cages. It doesn't even use the non-repeat for the cages, so it's just 11 cages. I like it. "17 cages. Okay, that doesn't have a meaningful count. Thank you, Peter. Nice submission. Enjoyed the puzzle. Do at least one more. I have to go back to the top on my queue. Okay. Remake it with all 12s. It's a sequel. Or 7 column 7s are bet cell. Ooh, parody dots. I just did parody dots for Sudoku Adventure, which was fun. Ooh, we're going to be coloring. Okay. This is called Mad Max 2. It's by Randall. We have normal Sudoku rules. Arrows. Digits along the line sum to the number in the bulb. Max arrows. The digit in the bulb. Okay, so standard arrows are digits on the arrow sum to the bulb. So if this was 1, this was 1, 2, and 4, then this would have to be 7, because 1 plus 2 plus 4 is 7. Max bulbs, or sorry, max arrows. Digit in the bulb is the max digit and must appear on the line. All other digits on the line must be smaller than the max digit. So if this was a maximum arrow instead of a regular arrow, and this was a 6, then 6 appears on here, say here, and then everything else is smaller. So that would work, for example. And then we have parity dots. Digits separated by a white diamond have opposite even-odd parity, and digits separated by a black diamond have the same even-odd parity. All right. So I've seen a similar puzzle, and the break-in was exactly here. So I think like this is based on that, or it probably was Mad Max 1. But think about it. If you think about this, these can't both be sum arrows, this and this, because these would have to be the same digit, because the sum would be the same. And so these plus this would be the same as these plus this. These would be the same digit. So one of these at least is a max arrow, but this can't be a max arrow because you can't repeat on the arrow. So this digit goes here. These are the same digit, and they're at least 6. And so then blue goes up here. Maybe I shouldn't use blue though, because we're going to use blue and orange for even odd parity. So so these are the same parity as each other, and one of them is at least 6. So this has to be a max arrow. So, oh, that's cool. So green is on here, right? And these are all the same parity as green. But the only way this would be a sum arrow is if green was 6. But then, first of all, that would make it the max on the arrow. That if it was a sum arrow, we would have to do 1, 2, 6, and those aren't the same parity as each other. We'd have to do 2, 4, 6, which is way too big. So it's a max arrow, but green is not allowed to be the max. So we have some other digit up here with green that's bigger than green, which means green cannot be 9. Well, green also can't be 8, because that would be the max of the evens. Which means there's a 1 and a 2 on here. Ice Cube is saying, for fans of killers like the last one, search out the Race to 37 series. Bremster has a great series of solves. Awesome. Cool. So purple is going to be 8 or 9, because it needs to be bigger and the same parity as green. That means this is a sum, because we can't repeat purple in the box. I'm wondering about... So these are the same parity as each other as well. Okay, I already said that, but since row 7, column 1, 2, 3 have the same parity, don't they have to be 1, 3, 5? It's not a sum. It's a max arrow. It actually can't be 1, 3, 5, because then green wouldn't be on it. So I'm going to use lines to denote... we'll use blue for a normal arrow. And we'll use yellow for a max arrow. And we'll hope that that means something. Or how about orange for a max arrow? So this is the max... This is the max arrow. And this is the sum arrow. We have the exact same thing happening here. So this is the max arrow, and this is the sum arrow. And so, I don't know the best way to signify that, but whatever this is, it goes here. Means it's up here somewhere. All three of these have the same parity. This is at least 6 as well. This is a sum arrow. Which means this is a max arrow. I'm wondering about this. Yellow could be purple, so we just need to remember that. If this wanted to be a sum arrow, it would have to be 1, 3, 5, adding to 9. Which would make this a 9. Ron says row 8, column 2, 3, alternate parity, so it has an even. Okay, so that's an interesting point. So if all of these are even, then we're out of evens. And so we'd have to add to 8 using only odd numbers, and that's impossible, because 8 is even. Very nice point. 3 odds always add to an odd. So this can't be 8. Purple has to be 9, which makes green 7. Very nice spot. So these are all odd. And I actually don't need... I don't need these colors. Let's get rid of them. And let's just say this has a 7 and a 9 on it. And so now... I don't know what I'm saying with now, but... Well, 2 can't go up here, and it's not here, so 2 is on the 9 arrow. So it's either 2, 3, 4, or 1, 2, 6. This is not 9. Ah, so we know this is 1, 2, 4. So we need a 4 as well down here. So this is 2, 3, 4. So I need 6 and 8 here. So this is one of the 6 8s. The other 6 8s over here. So this is not 1, 2. It could be 3. It's not 4. It's basically not even. It's 3 or 5. And then these are 3, 5, 6, 8. These are 3, 5, 7, 9. Wait, where's 1 go? 1 goes up here with the 7, 9. Wait, these can't be 3. Okay, so this is the 3. Sorry, I'm a little over the place, but this is 1, 7, 9. Right. I figured it out. Okay. There's definitely a 5 in here. We knew that. We know these are opposite parities of each other. Because if these were all the same parity, they'd all be odd, and we wouldn't have an odd to put down here. And they're certainly not all even. I don't know if I want to signify that in any way, but... maybe I should start coloring known odds and evens. Just to get started on that. The only odd up here could be a 5. What are we doing next? I need 1, 5, 6, 8, 9 down here. Can this really be 1, 2, 3, 6? This would have to be even. I guess it could be 8 with an 8 over here and it would work fine. Or a 4 with a 4 on here. Oh no, it couldn't be a 4, so it would have to be 8. Ron thinks row 3, column 4 can't be 6. We need 2, 4, 6 on the max arrows. That's true. That's true. If this was 6, this is a 1, 2, 3, and now these need a 6 on them, so they'd need to be 3 evens, and they'd have to be 2, 4, 6. So we have too many 2s going on here. So it's definitely not 6. Does 7 have a similar issue? Well, 7 is 1, 2, 4. So we'd do 7, 5, 3, and that would actually work. 8 would require 3 evens on here. So we'd only have 1 even left. So this would have to be 3 odds adding to 8. But 3 odds add to 9. Yeah, so 8 doesn't work. 8 means these are even. And I'm not going to do... oh, no, sorry. I would do an even and 2 odds to add to 8. Never mind. I'm being silly. That would work fine. Darn it. Okay. I don't know. I thought it would need to be 3 odds. That's completely wrong. If I could roll out one of these, that would certainly be nice. Seven is the more restricted one, because we would be 3, 5, 7 up here, and 1, 2, 4 here. So we'd be 6, 8, 9 here. That would be a 6, 8, 9 triple. I mean, it's cool, but there's no problem. Well, no matter what, 9's not on any of these. So 9 is up here. And whatever this is does go here, but the other one goes here. So there's a 7 or an 8 up here as well. One, 3, 4, or 1, 2, 5. A little stuck. Here tonight says row 6, column 6 can't be a 9 because you will have the arrow, and row 4, column 6, max of 5. I don't know if I follow that. Okay, so if these are, okay, I got it. If these are 9, then this is odd, but it can't be 7 or 9, so this would be a 5. But couldn't we just put a 5 on here and be happy? It wouldn't be able to sum, because these would sum to at least 15, and these would add to 14. So this wouldn't be a sum, but why not just put a 5 here and be done with it? Nebu says, I think the upper arrow in box 3 has to be max. Reasoning's a little convoluted. Well, the only way it's not max is if it's 135, which would sum to 9. So this would have to be a max arrow. So this would be a 9. And that would be a 9. That's all I see. These would be even. These would be whatever. I'm not seeing anything, but you maybe looked further ahead. One, 3, 5 in row 3. Okay, if this was 1, 3, 5 and this was 9, I guess Sayori's question is, where do 1, 3, and 5 go in this row? I could put 1, 3, 4 here, adding to 8 with a 5 here. And then 2, 6, 8 here. Doesn't seem to be broken. This can be a 7 though, because that all works out. This would be a 7, yeah. It looks like it might happen, yeah, to be honest. It's pretty clean. It's certainly viable. Oh boy. What am I missing? I wonder if it's this arrow? Thing is, it can be a max arrow, which is not very constrained. Yeah, the max arrow idea is interesting, especially the ambiguous part of it. We haven't looked a lot at this stuff, but I'm not sure what to do with it. Is it problematic for these to all be even? Because that's what would happen. If this was 1, 3, 5, these would be even and these would be even. We'd have odd digits here, we'd have even digits here and here. This would be even. Is that a problem? These would all be odd. This would be even. We know these would be odd. I think. Do we know that would be odd? Oh yeah, 1, 3, 5 is 9, so those would be odd. So this would be the odd and these would be evens. These would be odd. These would be even. That would be odd. It looks fine to me. Darn it. If these were even and these were odd, this would be the max arrow. So this would be even, which means we'd need 2 odds and an even on here. That would be odd. Oh wait, no, we need, right, there's only one way to do that. This would be 2 odds and an even, this would be odd. This would be 6 or 8. I don't know. Can't be 6, that's true. So it would be 8. So this would be odd, which means these would be odd. So there's 2 evens on here. So this would be odd. This is always odd. And this is always odd, apparently. Definitely intended step right there. Doesn't seem broken to me. Well, this would be 1, 2, 4. So, oh, well, that is broken, isn't it? The fact that this has to be 7 and this has to be 1, 2, 4 to add to 7 tells us that this is at least 6, but this can't be 9. And this had to be the sum because 3 evens is too big. This would be 8. It doesn't work. Can we boil that down to something a little bit? Okay, so if these were even, it has to be the max arrow. This would have to be 8 because 6 would use 2 2s. That makes this a 7, this a 1, 2, 4, and now how do we add to 8? There's a 6 on here somewhere. Okay. So these are odd. These are even. Doesn't mean this is the sum, though. Just means they're odd. But no matter what, this is odd, because either this is a max arrow making this odd, or it's 1, 3, 5 making this 9. So this is definitely odd. So it's either a 9 or I guess it's 5 or 9. Can it really be 5? Can't sum to 5, so this is 9 no matter what. So these are even. So we need, this is an even and an odd, right? Which is odd already. So this has to be even to get to 9. We know there's a 9 up here. These are all even, true. Stop. We don't know which arrow is the sum. Oh, true. Just this here, right. These are even. I mean, this could even be a 2 with a 1, 2 here. As far as I can tell. Nine somewhere in here. Oh, true. We need a 1 or a 2 on here to sum to 6 or 8. 6 needs both of them. So yeah, this can't be a 2. I think it might not be able to be a 4 either. Oh, this has a 1 on it. Right. So this can't be 2 or 4. Well, hold on. If it was, okay. 2 for sure. If this was a 2, then this has 1, 2 pair, and that doesn't work. If this was a 4, it's not adding to 4. So this would be a 2, 3 with a 4. And so this would be maybe 1, 2. 1, 2 adds to 3. 1, 2, and 5. That would work. Okay. So this can be 4, 6, or 8. So 9 does not go on here. 9 does not go on. Okay, so 9's up here somewhere. I'm sure that's helpful. What about 8? If this was 8, we could put an 8 here. If this was 8, 8 would be here. I feel like we could do more up here, but I'm not sure. If we wanted this to sum to 9, what would it be? Is that an interesting question? Antonite says, so the arrow in row 4, column 6 can never be sum, right? Well, why not? Oh, right. Yeah, it can never be sum. That's true. This is sum. So the sum of all these is at least 15, and there's no way we're reaching 15, right? So this is always a max arrow. So let's say purple goes here somewhere. Let's connect that. Let's connect this. Why not? I don't know. Maybe I don't want to do that. True. I actually pointed that out earlier and I forgot about it. So yeah, this goes here. Bunch of odds in box 5. This is the last even, true. So all of these are odd. Which means that this is always odd, because it's either the sum of 3 odd numbers, which is odd, it's actually 9, or it's this is on here, which means it's odd. So anyway, that's odd, that's even. This could be 2 odds, adding to even. We have all our evens in row 5. True. There's an even on here. Purple is even. So that's all our evens for the row. So these are all odd. These are even. Ah. Do we care? Okay, so this is going to be an even and 2 odds. 1, 2, 3 still works. Right, so the last even's on here. So this is odd. Sayori says, well, 9 in box 5 is on the diamond for what it's worth. True, 9's just placed. One of these is a 9. If this was a 9, this would be 135. These 9s point. Told you it would come in handy. I was completely non-sarcastic about that. Totally. I have all odds in column 4, apparently. Ah. Ooh, nice. Yeah, there's an odd in here, so the rest of these are even. And I'm going to blow your mind. 7 is not even, so this has to be 8. So, 8's up here, right? Because there's no way this is an 8. Which means 8 is in here somewhere. Well, we can't have 3 odds or... Oh yeah, we know this is a max arrow, and so then 8 has to go here. Or to be on its own max arrow. Which means these are even, and these are from 2, 4, 6. So we have all of our evens in the row. So that's... Sorry, yeah, those are odd. This is even. These sum to 8, so there's a 1 on them. There's a single even. Does that help? It doesn't matter. It's always going to be 2 odds and an even. So it's 1, 2, 5, or 1, 3, 4. So there is a 6 up here. So these are from 2, 4, 8. What are people saying in chat? Oh, I missed a lot in chat. Right, the last even is on this arrow, so these are odd. Okay. I think we said this was always odd, but I'm not sure if that's true. Okay, so there's 1 even here. There's at most 2 evens here, so this is even. Interesting. I think that means this can't be 135, but I'm not sure. Right? Because there's exactly 1 even here. There's exactly 2 evens here. So we need another... Oh, no, sorry. No, I'm wrong. There's this even. So 2 evens, 1 or 2 evens. We don't know what this is. Never mind. I got confused. Column 1 has all its odds. That is true. So these are all even. That's not 3. So this is not 8. It's 2, 4, 6. I think this could be 8 though. Oh, it's part of the 8 sum though, so it can't be 6. So this is 6 or 8. I wonder if it's yellow. That's the 1 even, so these are odd. So this is either 1, 2, 5 or 1, 4, 3. Okay. So this is odd, which means it's not yellow. So this is even. So this is 2, 4, 6. This is not a max arrow, so this is a sum arrow. Good point. So it's not a 2. I guess it could be 4, 6, or 8 though. Oh, it can't be an 8 either. Interesting. So we have, oh yeah, we have all of our evens in this column. So these are odd, which gives us the 6 and the 5 and the 8 and the 6 and the 4. This is a 1, 3. No, stop. What's wrong? Oh, 6 is not even? 6 is even. 6 is not odd. Well, that's not as exciting. Well, this is even. So this is 3. This is a 1, apparently. Well, this is always 1. Interestingly. So this is a 1. Let's see. I'm waiting for 135 to be impossible here or something, but maybe it is 135. This 3-5 goes over here, because this 3-5 looks up. But that's not that helpful. This is 3-5 or 7. Sees a 1 and a 9. Row 9, column 4, I'm told. Sees a 2-4 pair and an 8, so it's a 6. Nice. This is 2-4 or 8. Not an 8, apparently. Yep. These are 3-5, 7. If this was a max arrow, it would be 5 or 7, not a 5. If it's 1-3-5, then it could sum to 9. Right, that's all that was left for the column. This can't be 7, though. This is also 3-5, 7, not a 3 apparently. So this always has a 3 on it. So this is not a 3. I'm gonna put 2, 4, 6, 8 on these just so that same thing here. Oops. Oops. Zero's even, but there's no zeros. So 7's in one of these two. Okay. Well, that's interesting. 7's in one of these two. So 7's not here. 7's not here. I would say 7's not in a sum that goes to 6 or 8. So this has to have a 7 on it. So this has to be 7, 8, adding to 8. So that's 6 with a 1, 2, 3. That is very nice. That's a 6. That's a 7 and a 3. That adds to 9. I'm glad we got a 1, 3, 5 adding to 9. All of this is just suddenly a thing. I'm going to get rid of the yellows here. Oops. That's the 6. That's a 7. Very good progress there. These are 3, 5, 7. You can clean that up a little bit. Oh, the 7, 8 pair looks left, so that's 5, 3, and 7. These are... Let's see, we have 1, 2, 3. Okay, I don't need these purples. That's confusing me. We have 1, 2, 3. We need 4, 5, and 9 here. That's not a 2. This is... We don't know what color that is. Okay. What did we learn? That was a lot. Box 1 needs a 7. True. Goes here. So this is 5 and 9. Okay. We need... If we had 2 odd digits over here, then they would be 5 and 7. Actually, we need a 7 on here. One of these is 7. So this can't be a sum. So this is the max. This is the max arrow. That's a 9. And this is the sum. Wow. Okay. So it ended up being 1, 3, 5. That's fun. And now we get to redo the logic we looked at earlier. These are 1 and 3. We can place them. I totally knew that before doing that. This is a 5. These are even. 2, 4, 6. So that's the 4. 1 is odd. These are even. Very cool puzzle. That was tough, though. 2 and 8 here. That's the 8, that's the 2. So the 2, 4 pair. These are all odd. This is odd. And it's a 5. So we only have one more odd. This is the odd, so that has to be the 7. These are evens. These are 2, 4, 6. 6 can only go here. We have 8 and 7 here. I'm gonna good lift the rest. Okay. These can't be 2 or 4. What do we got? 3, 8 pair gives us a 6. 2, 4 pair gives us odds for the rest of the column. 1, 3 pair, so that's not a 1. What am I missing? Eight in box 3, certainly helpful. Bet's was an 8. I win the bet. Yay. Thank you, Randall. Let's see. I need an even, but okay, what am I missing? Oh, this is an arrow that sums to 8. So this is a 4. Too much going on. But that certainly helps. Nice. Sweet. And we finished just on time. I enjoyed that puzzle. Thanks, Randall. I think that if I were to go back and try to do this puzzle again, I would struggle again. I don't remember all the steps. There was a lot going on, for sure. And it would obviously be a smoother solve, but I wouldn't be able to just like walk through it. That's interesting. I feel like we were a little bit looking at the wrong places for a while, and so that probably confused me a bit too. Tricky break-in with the arrows on column 6. Yeah, there was something interesting about that, for sure. I totally remember what it was. All right. Maybe I'll have to rewatch the solve at some point. Cool. Well, thank you, everybody. Hi, Eric. You're getting my thank you screen. Thank you to my super supporters, The Asylum, Peter, David Ratner, Sotek, Franco, Mathgeek, Kenny, Woofer, and Rise to the Equation. Thanks to all my members and patrons. Please submit your puzzles. Thank you to everyone who submits their puzzles. I need puzzles, so thank you. And next stream is Saturday morning for more Sudoku. So hopefully see you there. Have a great night.